Welcome back to the Ductile series of videos. In this video we'll discuss some of the design implications of finishing steel structures, both for exposed and hidden steel. Now, finishing is important to get right because again, because steel is a prefabricated system, we need to make sure that the steel comes to site in most instances pre-finished. It's very difficult to get good quality steel finishes on site, and it means that it's imperative that we get the coordination and geometry of steel correct beforehand, because refinishing a steel element so that it matches in with the rest of the colours and finishes of the steelwork is very difficult indeed. So again, it's another aspect to design with steel that requires a high degree of resolution up front. Now, the first quite common steel finish is galvanizing. Now, there's two types of galvanizing. The most common for structural steel is hot dip galvanizing. Now, hot dip galvanizing is something that's done in a factory, and it's not done in the same factory typically as the steel fabrication. Now, the reason for this is the galvanizing process uses quite a range of toxic chemicals, and these toxic chemicals and where you can produce these toxic chemicals is limited, so to certain industrial estates that can accommodate the higher levels of toxicity. So typically what happens is that the steel is fabricated in one factory, transported to the galvanizing factory, and then either returns back to the factory that made them for holding and redistribution, or if the workflow is organized very well, then the elements leave the galvanizing factory and arrive direct to site. But this requires a great deal of coordination. So it's important that we get the steel geometry and detailing right, because not only is it virtually impossible to change it on site, but there's so many consequences in the steps that are needed to produce the steel and finish it. So the typical workflow for galvanizing is that it would leave the factory that fabricated the steel elements, transported by truck to the galvanizing factory. Now, one of the important aspects about galvanizing using a hot dip galvanizing method is that the size of the galvanizing bath dictates the overall size of steel elements that we can produce. There's no point in making very long span structures that will not be able to be galvanized if that's the intended final finish for them. So it's important to understand the capacity of hot dip galvanizing before you design the geometry and size of your elements. The other thing as well is there's the propensity of elements being damaged in transit. So again, whilst we're sort of thinking of how the elements are going together, how they're transported and how they're lifted when they're moving from one process to another is also something that needs to be accounted for. Now, as we were saying, the galvanizing process is rather toxic. There's a series of preparation baths that are needed to prepare the steel prior to the hot dip zinc galvanizing. There's a process of degreasing, which for black steel gets rid of a lot of the impurities and things that will prevent it for the galvanizing from sticking or bonding to the material. There's then an acidic sort of finish, which is pickling, which gives a sort of slightly rougher dimpled effect, so that again it's something for the galvanizing to grip to. And then there's a fluxing, which is sort of like a pre-finish that protects the steel a bit between the preliminary and the sort of hot dip galvanizing. Now, the zinc bath is warmed to approximately 450 degrees, and then after it's been dipped and coated, it's then quenched to seal the steel. Now, it's also important to recognize that sometimes that sort of dipping and quenching can deform steel as well. So if you're using particularly small elements, and this is common for like re-stumping projects for Queenslanders using quite tall square hollow sections, if the slenderness of the columns exceeds, I guess, the capacity of the hot dip galvanizing, you can actually get some deformation in the elements, and it's worthwhile bearing that in mind. Then after the elements are finished, they then are transported either back from the galvanizing factory to the manufacturer or straight to site if the workflow is very well organized. Now, the other important thing why we should get these things right is that sometimes it is important, or it's necessary, unfortunately, to make modifications to the steelwork because the coordination and the design thinking hasn't been thorough enough. And in these instances where one has to sort of weld on new plates or something like that on site, then we have to use cold galvanizing, which is basically a paint-on finish. Now, the cold galvanizing is a less superior finish to the galvanized product, and what it does mean as well is that it's a sort of a weak point for corrosion to come in, and it's somewhere that you always have to come back to and refinish with more cold gal over time. But if it's exposed galvanizing, it's even worse because the cold galvanizing will never blend in with the hot dip galvanizing, and this can be seen in certain poorly detailed exposed steelwork. Here's an example of a sunshade outside the UQ Centre at the University of Queensland St Lucia campus. Another process that's used perhaps more for screens and for smaller metal elements is powder coating. Now, powder coating, unlike painting, allows for much higher build thicknesses onto the material, which gives much better density of colour and also much more protection to the steel. And it comes in a range of different finishes and colours that are often quite interesting and more metallic and more intrinsic to the nature of metal themselves. Now, similar sort of process, most powder coating is done in an off-site in another factory, so elements again need to be transported from one site to another. Although the process for powder coating is perhaps less toxic than galvanizing, it's still a fairly intensive and quite dirty process. Now, typically what would happen is that elements would come in, they're cleaned or degreased, particularly if they're black steel, and the spraying is done in controlled environments. Now, there's a electrostatic or a charge onto the powder that means that the powder is actually attracted to the steel and attracted to bond to it. So it's not like paint in that respect. And then this dry powder is baked in an oven so that it bonds and gives a typically quite a high gloss, very good coverage, very dense coverage of colour. Again, in a prefabricated system, this needs to be, it's very difficult to actually replicate this on site, so everything needs to be done, the geometry of the steel needs to be very, very thoroughly thought of before it goes into powder coating. And then the elements, which can be really any colour you want, are then transported either back to the factory or straight to site. In some instances, it is impossible to pre-finish all elements, and there are levels of finishes that have to be applied to site, and typically we see this very commonly with large infrastructure like bridges and so on. Now, it's quite labour intensive, and the type of finishes which are done on site usually applied with a brush means that the level of quality of finishes is not as good, and it means that the build up of paint needs to be thicker. So for most bridges, for example, particularly older bridges, basically they just a constant regime of painting in order to keep the steel protected. It's just particularly in situations where it's nearby salty environments, this is an ongoing issue. And you can see here it comes with its problems in terms of access and safety, having to erect scaffolding or have special harnessing and so on in order to access the different parts of the bridge. Now, an architectural finish that's used quite frequently, and also it's referred to as bridge paint, is what's called a micaceous iron oxide. Now there's many different proprietary names. The Dulux example here is called Ferrador, but basically it's a similar type of high build, very thick paint, solvent based, with a sort of metallic fleck through it, and the reason architects love it is because it catches the light in a certain way and looks quite attractive. So you see this micaceous iron oxide used quite a lot even for architectural steelwork. For quite colourful steel and for steel that needs to be sort of high quality, high colour, and often these finishes are done again in a factory that is sprayed. Sometimes it can be done actually in the factory that manufactures the steel, because creating a spray booth is not as complicated as, say, for galvanizing or for powder coating. But using a sort of a 2-pack polyurethane paint will give a good coating to the steel, but although the manufacturers will claim it gives a very good and durable coating, over time the breakdown in the sun, there will sometimes be a chalkiness that appears on it, and particularly then over time this needs to be maintained. So it's good for steel that's intended to be decorative or colourful, but in some highly corrosive environments it's perhaps not ideal, but a very good choice. Well, that is not by any stretch of the imagination a comprehensive list of sort of trade-based finishes to steel, but it does cover the main basic finish types. It's important to do the research up front as to the sort of capacity and how the finishes are applied, and working backwards from this, how that affects the design. Again, as much pre-thinking into the whole system from the elemental parts through to the finishing is absolutely essential for architects to get involved with, so that the whole steel system comes together smoothly. Thanks again for listening.